Hi, welcome back to the third session on an introduction to programming for teachers using Python. In this session, we're going to continue talking about fundamental data types. In the previous session, that's session 2, we talked about integers and floats in quite a lot of detail. And in this session, we're going to talk about strings, and then we're also going to talk about inputs and outputs. So again, we've got this idea of a flight kind of billboard. And in the first column, we've got the flight numbers, and these were numbers. We typically represent these as integers. And then we talked maybe about the idea that we've also got destinations, which are a string, a series of characters, right? And these would be represented by things called strings. So a string is a data type which holds a sequence of characters. In Python, string literals are specified by enclosing a sequence of characters within a matching pair of either single or double quotes. So for the this is a string section here. It's being enclosed by a pair of quotation marks. There's one, and there's the second, enclosing it. But we can also use single quotation marks, which is the same as the apostrophe key. So this section here, in between these two apostrophes, which says so is this, sorry, with a full stop, is also a string. The reason for this, to allow for allowing both double quotation marks and single quotation marks, is it allows both types to be used in a single string, so we can do quotes inside strings. For example, the string is he said, and then the quote hello. We can use this. We can use the second type of quotation mark, or the double quotation mark, to indicate that there's a quote inside a string which we've created using single quotation marks. Okay, so a string is the data type, and in a string there are a number of characters, and the number of characters in the string is called the length of the string. For example, the length of Harry is 5. We've got H, which is 1, 2 for the A, 3, 4 for the 2 R's, and then 5 for the Y. So we have 5. The length of the string is 5. And you can compute the length of a string using Python's len function. It takes a string and returns the length of the string. So the length of the string world with an exclamation mark is 6. World is 5 letters long, and then the exclamation mark is a 6th character. A string of length 0 is called the empty string. It contains no characters at all and is either written as double quotation marks, so 2 double quotation marks, as in 1, 2, or 2 single quotation marks, 2 apostrophes, 1, 2. You can add one string onto the end of another string, and this add is actually called concatenation. So let's say we had the string Harry and we had the string Morgan. Then by adding fname, which is the variable holding the string Harry, and lname, last name, holding the string Morgan together, we get the output, we get the resulting string combination Harry-Morgan with no space in between them. If we wanted to have a space in between them, we just have to concatenate a space in between them. So we have our first name, or the value stored in our first name, concatenated to a space, concatenated to the value stored in our variable lname, or last name. And this time we'd get Harry space Morgan. Harry from fname, the space being concatenated here, and then Morgan from last name. To concatenate a numerical value to a string, we need to convert the numerical value to a string using the string cast call, or str cast call, and then we can do concatenation. If we don't do this str call, this str cast call, we're trying to add a string to a numerical value, which Python will throw an error at. You cannot add strings and integers together, but if you convert the integer 7 into a string, then you can add them together, and that add becomes concatenation. Displaying strings, you can do that using the print function. So let's say we had total equals 123, so the value 123 is stored inside the variable total. And then using the print function, I could say print, and then Python would print out the total is, which is a string, with total afterwards. The print function can print integers, floats, and strings. You do not need to convert necessarily the integer or float into a string to print it. Okay, so we can print this 1, 2, 3 without having to convert that numerical value into a string. You can also produce a string that is the result of repeating a different string or the same or part of a string multiple times. For example, you could have dashes is hyphen times 50, so the string hyphen times 50. What that's going to do is it's going to repeat this hyphen string 50 times. Okay, so the multiplication of integer by string is going to repeat the string a certain number of times. Okay, and it results in this rather long string here of hyphens. So I did mention a couple of slides ago about the str function. It casts one data type to another. It casts whatever you give it as input into a string, and we can use that to convert between numbers and strings. So let's say our balance was 888.88. That's a float. Dollars is 888. That would be an int. Then I could turn my balance from a numerical value, that floating point value, into a string using str balance. I could do the same thing with dollars. I could turn the integer value, 888, into a string using the str call by providing dollars as the argument. So str open parentheses, dollars close parentheses. Conversely, we can turn a string containing a number into a numerical value. And the way we do that is either using the float cast call or the int cast call. So let's say that we were given the ID of 1729 as a string. By calling int on that string, it converts the string into a numerical value that we can then add and multiply and divide like we can with any other numerical value. Similarly, if our price, or if we were given 17.29 as a string, by using the float cast function, we could turn that string 17.29 into a numerical float value that we can then, again, do addition, multiplication, and so on with. The second conversion here, the idea, not the top half of turning integers and floats into strings, but turning strings into integers and floats, is very, very important when we come to talking about user input. Because user input is by default turned into a string. So if we have the user enter a number, that number is going to currently actually be stored as a string. If we want to do normal arithmetic with it, we're going to have to turn it into either an integer or a float. Okay, so then we're going to kind of move on to thinking a little bit more about individual characters inside strings. So each individual character inside a string has an index number. The interesting part of this, maybe for people who aren't coming from a computer science background, is that we start indexing from 0. So if our string of characters was chars space here, then the C is actually in the 0th position. Our first character in our string is actually at index 0. So the square bracket operators will return the character at any given index. So let's say the character string is Harry. The start of Harry, so if we called name with the position 0, that's going to return the H. And if we called name on position 4, it's going to return the 4th character. The character in index position 4, which is the letter Y. Okay, so your string is made up of a series of characters. The characters are indexed from 0 onwards. Okay, and we have a bunch of different operations we can perform on strings. So the plus operator acts as concatenation. So if we had the string pi, and then we had pi concatenated with thon, that's going to join together and create something, a string Python, and then store that in the variable string. Okay, so when applied to strings, the plus symbol denotes concatenation. The print function prints out a message or prints out whatever's contained within the parentheses to the shell. We can still use concatenation inside this print function, so we can concatenate please with enter your name, which is quite a nice thing to do if maybe your editor isn't particularly wide, so you can split up your message over multiple lines, but when it actually is printed to the shell, it's going to be joined together. In the third row of the table, we've got the idea of if we try to add the number 49 to the string is, that's going to cause an error. So if we want to concatenate a string to a numerical value, we have to turn the numerical value into a string before we do so. So we're using the str casting function to cast the integer data type of 49 and turn that into a string. Okay, and then we're setting the variable teams to be 49 plus ERS, so the 49ers. So again, in the comment here, because 49 is an integer, we have to convert it to a string before we use concatenation. Greeting equals H and S, and then we've called a len function, which is the length function. This is going to return the length of whatever we provide as input. So we provide greeting as our input, which is H space and space S, and then we've assigned that value, the return value from the length function, to the variable n. In this case, n is going to be set to 5 because all of the spaces and all of the symbols also count as characters. So H is the first character, then we've got a space, so 2, the ampersand is 3, another space is 4, and then the S is 5. So we have 5 characters in total. Let's say we had the variable called string holding the value Sally, and then we work out what character is in the first index position, the 1 index position, not the first index position, the 1 index position, or index 1, and that's going to return A, because we have to remember that we index from 0. So string, the index at 0 is the S, the index at 1 is the A, the index at 2 is an L, the index at 3 is an L, and the index at 4 is a Y. Okay, we index our strings starting from 0. So then the final line, which says last equals string, len string minus 1. So let's kind of take it step by step. Len string is going to return the length of the string. We're going to take away 1 from that, and then because it's in square brackets, we're going to return the character at that position. So this, all this right-hand side is really doing is just returning the character at the last position. And the reason that is because if you have a string of length, let's say 5, then they actually index from 0 to 4. So you'd need to do the length of the string minus 1 to get 4, in the case that there were 5 characters, to return the last character, the character in the last position. Okay, I would suggest having a little go. Maybe copying these down, opening up Python, opening up a new file, and have a little go at joining some strings together using concatenation. Maybe having a go at using concatenation inside a print statement. The idea of casting values or casting integer data type values to string data types. Getting used to how the length function works and the fact that it includes spaces and exclamation marks and things like that. Indexing from 0 is going to be a really, really common error that people have. So trying to familiarize yourself with the idea that we now index from 0, and then this last line of code, maybe running that through with an example to get used to the idea of the length may be something like 10, which means that if we're indexing from 0, the last position is going to be 9. Okay. So we've talked a little bit in the previous session about functions. We're now going to mention something called methods. So in computer programming, an object is a software entity that represents a value with a certain behavior. The value can be simple, such as a string, or complex, like a graphical window or a data file. The behavior of an object is given through its methods. But unlike a function, which is a standalone operation, a method can only be applied to an object of the type for which it's defined. For example, you can apply the upper method to a string. And then here's the example. So we have something like John Smith. If we then say name.upper, that's going to turn John Smith all into uppercase letters, and then store it in a variable called uppercase name. Okay, so functions are like general purpose, and they can be called and given lots of different parameters, whereas a method can only be applied to the object for which it's defined. So the upper method has been defined to work on objects that are strings. Okay, so these are some useful string methods that you may want to use. So dot lower is going to take your string and turn it into a lowercase version, so convert all of the uppercase letters into lowercase letters. Dot upper is going to convert everything to uppercase letters, and then dot replace old comma new is going to take your string and replace all the occurrences of the word old with the new string new. Okay, so it's almost like if you wanted to go through something and change all of the names, you could replace all of the old names with a new updated name. Again, definitely worth having a go at doing. Maybe write out a quick sentence, maybe make it use your name and then use the dot replace and replace your name with someone else's, and you'll see that hopefully the string will have replaced every appearance of your name with someone else's. It can be used for other things, but that's kind of a good example which demonstrates how it works. Okay, so then we've kind of got some interesting things inside print statements where we want to print almost punctuation or syntax, punctuation in some way. So if I wanted to print a quotation mark inside a string that I've opened with a quotation mark or I've declared with a quotation mark, I'm going to have some issues. Because when I then put the next quotation mark in, it's actually going to close the string. To get around this, we can use a backslash to indicate that the quotation mark is meant to be displayed as a quotation mark and not as a ending or opening of a string. Okay, so if I wanted to print he said and then in quotation marks hello, I'd have to put he said and then backslash quotation mark hello backslash quotation mark, and then these final quotation marks here are declaring that the information contained inside them is a string. Which then leads on to the funny question of, okay, how do I then print a backslash? Well, to print a backslash, you just need to preface it with another backslash. So if you wanted to print c:/temp/secret.txt, you actually need to put double backslashes in everywhere, so a single backslash will appear. Okay, again, take a second, try opening up your Python editor and using this backslash, try and get it to print a backslash, get it to print quotation marks, and so on. And then finally, we can actually use the \n to create a new line in a single print statement. So for the example here, we've opened up our string, we've got a asterisk, then we're saying start a new line, 2 more asterisks, start a new line, 3 more asterisks, start a new line, end the string. And that will print this picture on the right-hand side. Okay, these are very, very useful tips for formatting, and formatting is something that we're kind of just going to focus on near the end of this session. Okay, so we've maybe mentioned a little bit about printing and providing output, but there's also the idea of maybe wanting to receive input. If you remember back to the first session, we talked about input devices, the computer, and output devices. Here's an example of how we could get input from the user. So you can read a string from the console, this is the shell that we were talking about, with the input function. So something like name equals input, please enter your name, is going to print, please enter your name to the shell, wait for the user to provide a response, and store the response in the variable name. Okay. The issue that I maybe mentioned earlier in this session about that is it's going to store all of the information you provide as input as a string. So if you ask them to enter something like a name, an age, they're still going to store that age as a string and not as a numerical value, not as an integer or a float. So this is where we can use the int cast function to cast the input from the string data type to an integer data type. Or we could use the float cast function to cast the input from a string data type into a float data type. So again, we're going to, using the input function, we end up printing please enter your age to the console. We wait for a user to respond. The user responds. That value is stored as a string, and then the int function casts that value from a string to an integer data type, and then stores that in the age variable. Okay, I like doing this in a single line, but you can do it in multiple steps. So the above is equivalent to doing it in 2 steps. Firstly, getting the input, and then secondly, converting it into a number. So here, line 1 gets the input, and then line 2 converts that input from a string to an integer. Okay, and then we're going to talk about formatting. So outputting floating point values can look really quite strange. Price per litre is 1.21997. And that's not normally something that we would kind of go as far into. Especially if we're thinking about maybe less about maybe petrol stations, but things like in a shop, items are only ever really going to be represented to 2 decimal places because we've got pounds and pennies. We don't have a smaller denomination than that. So to control the output appearance of a numerical value, we can use formatting tools such as %.f2 or something like %10.f2. And what these do is they format how the variable is going to be displayed. So the 0.2f is going to display only 2 decimal places. So instead of displaying 1.21997, we actually only represent 1.22. And then the 10.2f is going to say we are given 10 character spaces, and only 2 of them are going to be used, or cut the value to 2 decimal places. So we then print out a big gap here, and then 1.22, where the entirety from here to here is 10 characters. Okay. So this is called a format specifier. Okay, I've got a big long list in a table to show you, which, again, we would suggest you pause the video and have a little play around with. So a bit more information. We've got this idea of formatting a string with the percent symbol. So it's common to print a formatted string rather than an unformatted string. We have format specifiers here, so %d and %10.2f. The format string contain 1 or more format specifiers and literal characters. So we're going to format 2 things at the same time. We're going to format 1 here with our %d and 1 here with our %10.2f. If you're only formatting a single value, you don't have to put brackets around the variable that you're formatting. But in this case, because we're doing 2, we need to contain them in brackets. Quantity is going to be the first value that's formatted, and then total is going to be the second value that's formatted. So that's kind of explained here. The values to be formatted, each value replaces one of the format specifiers in the resulting string. Quantity is replacing this format specifier. Total is going to replace this format specifier. Okay, so let's just justify a string. We're going to print but minus 10, so minus 10 is going to be 10 characters, but the minus is telling us left align it. The S is telling us it's going to be a string. And what we're actually going to print out is the string total with a colon. So the overall width that we've decided on is 10, and the minus is telling us left align. Okay, or left justify. We can right justify a number or a string or whatever we want by not using a minus symbol. So %10 is going to say we've got a width of 10 for this information. Right align it. The 0.2f is telling us it's a floating point number and only display 2 decimal places. So something like a price we might want right aligned with a certain number of a certain width, and then the value only represented to 2 decimal places. And you can print multiple values, and you can format multiple values simultaneously. So we're going to kind of combine our first left justification of the word total with our right justification of price. So this is our first value to be formatted. This is going to be our second value and how it's going to be formatted. So the first value that's going to be formatted is total with a colon. That's going to be left justified, and it's going to have 10 characters, and it's a string. And then our second value to be formatted is our price. This is going to be right justified. It's got 10 characters, and we're only representing 2 decimal places. Okay, and then when this runs, we get total with a width of 10. Okay, and then we have, and that's left justified, and then we have our price, which again has been given 10 spaces or 10 characters, and we're only representing, it's right justified because we haven't used a minus sign, and we're only representing it to 2 decimal places. Okay, so this is kind of the start or a continuation of the program for working out the price per ounce for cans versus bottles. You might want to pause the video and copy this down, remembering that the hash symbols indicate the start of a comment, and things like we're using all capitals separated by underscores for constants, and then we've got some user input, which we're converting to floats, some more user input, which we're converting to floats, and then some calculation here using variables and constants, and then maybe some division, and then at the very bottom we're doing some formatting, price per ounce, and then we're formatting the price per ounce variable. We're giving it 8 spaces or 8 characters to fill up, and we're representing it to 2 decimal places. Okay, so then this is the big long list of format specifiers which I mentioned earlier that you might want to pause the video and have a go at using. So %d is used when you use an integer. %5d is saying the space that we're allowed to fill is 5 characters long. Spaces are added so that the field width is 5. %05d is telling us we've got 5 spaces, or the field width is 5, but I want you to fill in the unfilled in spaces with zeros. So if you add a 0 before the field width, zeros are added instead of spaces. Okay, so compare rows 2 and rows 3. Okay, quantity colon %5d is going to print quantity and then give us 5 spaces to store our integer, and our integer was 24. Okay, so we've got quantity and then 1, 2, 3, 4, 5 spaces with our integer. Okay, %f is what we use when we're representing floating point numbers, and then something like %.2f is going to only print 2 digits after the decimal point. We can have something like 7.2f, which is saying the field width is 7 and only display 2 decimal places of this floating point number. %s is what we use for strings. We can use multiple we can format multiple values at once. So something like %d, %.2f is saying, hey, we've got an integer, this is how it's going to be formatted, followed by, hey, we've got a floating point number, and format it to so it only displays 2 decimal places. Okay. Strings are right justified by default. So %9s is going to say the field width is 9, and we're using a string. Because there's no minus sign, and by default they're right justified, the string is going to be right justified. So we've got hello on the right-hand side. If we use a negative field, so -9s, again, we get told that the field width is 9 characters. The minus sign is telling us left justify our string. Okay. And then finally, if you want to display a %sign, you can do % whatever value you want to display, and then a double %, so % is going to actually output a %sign. Okay, so have a little pause of the video, go into Python, and try and use some of these format specifiers to format your output in a way that's maybe more useful and more readable. So take a float and format that float so it only displays 2 decimal places. Take a string and try and left justify the string rather than right justify the string. Maybe try and do this row here, this row 4, where you've got both a character, you've got some character string, and then you've also got some other value inside, maybe an integer. Have a little play around with it. Maybe try and use this %% to output a percentage, and so on. Once you've done that, that'll be it for this session, and then we'll get on to session 4 of this Python tutorial.